Welcome to the University of Salford. My name is Hisham Al-Qadi. I'm the Professor of Architecture at the University of Salford, and I'm going to tell you today about the Living Lab. I'm the director of the Living Lab here, which is part of the Ignition project. The Ignition project aims to apply the top technology in green infrastructure in order to produce and promote a new investment model in order to let everybody try to invest in green infrastructure and come back and learn from us here to increase the green infrastructure in Greater Manchester by as much as 10%. The main aim of this project is we are looking into the integration of different technologies. So that we believe that the integration between different technologies, from walls to suds over there, to green roofs and some of the plantation over there, all that, it doesn't work by itself. We have to integrate those systems in order to introduce that great model. I hope you will enjoy that video with our technical staff, and I hope you come and visit us at certain point.
Here we're stood in front of the green wall. The green wall is split into 4 different planted sections. We've got the biodiversity wall, seasonal wall, pollinator wall and edible wall. The system here is a modular system with integrated attenuation and passive irrigation. The planters are mounted on a lightweight steel frame which is fixed to the wall. Interestingly, the tall biodiversity section is actually a 4-ton living wall. So that is actually the whole load of the wall is transferred directly to the foundation. So there's actually no load on the existing wall. The entire frame is tied to sliding fixings to transfer the load vertically. The foundation itself is a floating foundation. So the mass of the material excavated is greater than the mass of the new foundation plus the load of the living wall, which makes the whole system floating. In the living wall we've got integrated drip lines so that we can irrigate the system if the plants become dry. We've also got integrated soil moisture sensors in each individual section. The irrigation for the living wall is also split independently, so we can independently irrigate each section by remotely controlling solenoid valves, which can be set on a timer or they can be set to respond to the soil moisture settings. So we set a soil moisture parameter such that if the soil moisture does drop below a certain parameter, the irrigation automatically kicks in to the relevant area, and therefore it's the most efficient way of irrigating. Here we have the showcasing technology section, where we've got 3 outdoor screens which are showing real-time system data, ignition project information and construction photos and videos. We've also got a range of seating and prefabricated planters just to make the showcasing area a nice place to be for students to relax in front of the living wall. Beneath this area is 40,000 litre irrigation tank. During a rain event, the rainwater from the entire campus is directed into an existing surface water drainage system, where the water surcharges in an existing attenuation tank which is located below the ground here. During that rain event and the surcharge, we extract some of that rainwater and put it into our irrigation tank that has been installed above ground below the deck. The tank is 40,000 litres in size, such that during summer we should have enough water to irrigate all of the green infrastructure without having to top up with mains water.
Water that is extracted from the existing surface water drainage system is then distributed to each of the areas. So it's distributed to the living wall, the tree pits and green roof independently. So it's pumped from the 40,000 litre tank at an on-demand basis to each section.
So the whole point is we're using harvested water that would have otherwise gone to waste, and there's no need for mains water irrigation.
So water is pumped from the tank through this chamber, where there is a solenoid valve and flow meter, such that we can always monitor the exact amount of water that leaves the tank. The water is then pumped into this chamber, which distributes 3 ways to the tree pit, the green roof and the living wall.
Here we have the Suds tree pit, which comprises of 3 trees. The tree pit itself is installed entirely above ground. So The tree pit is encapsulated in a voided plastic structure, so the base and walls are made of a voided plastic structure, such that we can aerate the soils to reduce compaction and can also contain the tree roots. The base of the tree pit creates a reservoir of water with passive irrigation wicking cones, so we can actually draw water up by a capillary action to the tree roots on an on-demand basis to keep the tree roots at optimum soil moisture conditions at all times. The tree pit is cladded in 4 different types of cladding options. So at the base we've got a shiplap timber cladding, and then we've got a zinc metal cladding, corten steel and weathered copper. All the tree pits are topped with a timber topper to make it a nice seat. We've also got integrated plug sockets to make the tree pit more of an amenity. The water level in the reservoir is monitored using an ultrasonic level sensor. We also have an actuated outlet such that we can completely empty the water reservoir or close the outlet and allow it to fill up entirely. We also have integrated soil moisture sensors in each of the individual tree turrets.
So here we have the green roof, which is split into 7 elements. We've got the sedum planted areas, the wildflower planted areas, perennials, a brown roof, we've got a tree pit, raised planters for testing, a climber wall and a traditional living wall. The green roof comprises a drainage layer to allow water to freely drain through the existing outlets. Then on top of there we've got a water absorbent tile. In between the water absorbent tiles we have drip lines such that we can irrigate the system during dry spells at an on-demand basis. The tile itself is topped with 50mm of soil. For weight reasons we are restricted to the depth. However, because we have the irrigation capabilities, we can comfortably sustain plants with 50mm of soil. Each of the 7 different areas are independently irrigated through this manifold here. So we've got 7 different sections with solenoid valves to remotely open and close the water supply, and then flow meters such that we can always monitor the exact amount of water that has gone to each independent section. Each area also has its own soil moisture sensor, so we've got 1 per sedum, wildflower, 1 per planter, tree pit, green wall and climber wall. So based on the soil moisture in each area we can remotely batch feed the particular area, or we can have it all on one continuous system. Here we have the roof tree pit. The tree pit is an extremely lightweight tree pit such that we can actually have it on the roof because there's such a tight loading of 75 kilograms per square metre. The tree pit itself is situated directly on a column, and then there's a 5-metre diameter exclusion zone around the tree pit such that the average weight of the area is still within the loading requirement of the roof. The tree pit itself is built with a voided plastic structure, again similar to the ground level, such that the soil is aerated so it doesn't become overly compact, and then we also have a water reservoir in the base with passive irrigation such that we can irrigate the tree passively at an on-demand basis. So the tree is specifically selected so it doesn't grow too large. Also the tree pit itself is specifically sized to contain the roots, so it's similar to a goldfish. The tree will only grow based on the size of what it's planted in. So the tree roots are restricted to a certain area and soil moisture content to restrict the growth from a weight perspective. Dotted around the roof we have log piles, rubble mounds and pebble mounds to create habitats to increase biodiversity for invertebrates and the like. There's a timber path that goes all the way around the perimeter of the plant room and to all the planters on the green roof. The timber path itself was made off-site, prefabricated into modules such that we could do the installation extremely quickly without the need for power tools. The path itself went in a matter of hours.
It was important for us that all the construction and installation of the green infrastructure within the campus would happen with minimum disruption. Most of the construction had been made off-site and brought to the campus. This is not only for the convenience of the university, but also to mimic some of the construction that would happen within urban areas. There are a lot of research going on and continuing to go on using a complex network of sensors that would be able to monitor every single drop of water in different species of plantation, whether it is on the wall or the sod trees or the plants on the roof. We would like to make sure that these species, and mimicking and monitoring the biodiversity as well, would survive in different environments and in different climatic conditions. And it's not only about sensors, but it's all about human interaction as well. So we monitor how the people and the population, and we engage with the local population as well, how they view that construction, how they accept that construction, how they interact and enjoy green infrastructure. Right, I hope you enjoyed the video so far and the introduction to our Living Lab. There are much more than that. Please come and see us, talk to us, contact us. It is very important to promote that sort of technology for the future. I want you to believe that that is the future of our built environment. We need a green environment. We need a green and healthy environment for our children. So support us, be with us, and I'm looking forward to working with all our partners in Greater Manchester and beyond.